Good morning.
Happy birthday, Miss Jennifer.
Oh my goodness. Thank you.
Happy birthday.
Happy birthday. Thank you. Thank you. Thank you. 29 again. I wish. I don't know. I don't know if I dare or not. That'd be interesting. Over here, I'm getting ready to pass back some papers real quick, and then we'll be getting started. One of the things that we're going to do before we get started doing our review of 5 is when I pass back the 4, there's a couple of things, a couple of corrections that I want to go through on the 4 test to make sure everybody's good with that. So hang on just a minute. Okay, listen. We have previously turned in 4-1, 4-2, and 4. You gave me corrections for 4-1 and 4-2. So I don't have 4-4, 4-6, and 4-7. So look for those. All right. I passed that last week. Everybody's good at your house?
Mhm.
Wonderful. Focus. Ballot. April. So what I did on these is I had them put your as-is score. So yeah, emailed you yours that time, so with Alex. All right. So what I want to do is I want to go through and actually, April, hold on just a minute. I'm going to take a picture of yours and text yours to you so you can look at it. And then Keely, did you get yours? I emailed yours to you, your test 4.
Let me grab my phone real quick and I'll make sure I have it. But I think I got it earlier today, so thank you.
Okay, you're welcome. I want you to look at them. I want to go through them and be sure to answer any questions because the scores on these were a good bit lower than the previous tests. So I want to be sure to answer questions before we move on. And as we're going through these, this is time, you know, we won't have time for you to fully set and make corrections, but at least you'll be able to, we'll talk through them. You can make corrections and then bring them back, okay? So I'll give them a minute. So I just sent you yours. I guess Keely's getting hers. Okay, so notice in the beginning, 1 through 6 was just naming the triangles that met the criteria. Equilateral means what? Huh? All sides are equal. All 3 sides are the same. Isosceles means what? How many sides are congruent in an isosceles? 2 sides are congruent. Scalene, how many sides are congruent? None. Good. An acute angle or an acute triangle means that what about each of the angles? The whole, every single angle is less than 90 degrees. Okay. A right angle has at least one angle that is 90 degrees, and an obtuse triangle has at least one angle that is over 90. Perfect. Okay. So if you missed something with 1 through 6, look and see what you missed and why you missed it. Okay. Look to see, did you remember that with, and I think most of them probably had to do with the angles. you know, just because it has an acute angle does not mean it's an acute triangle. It has to have all angles acute, okay? So you'll want to be real careful with that. A big one that was missed was number 8. Look at number 8 for a moment. What 2 pieces of information do I know for sure in that diagram? Number 8, look at the picture. What 2 pieces of information do I know for sure? I know that I've got right angles. And when I have a right angle, what is the side opposite the right angle called? The hypotenuse. Okay, so in that one, all I know is a right angle and a hypotenuse. So when I'm looking at side, 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 angle, side, angle, angle, side, or hypotenuse leg, what do you think that one's going to be? Hypotenuse leg. Okay, good. That was number 8. Okay, so basically with each of these, you're looking to see, is it side, 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 angle, 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 side, or hypotenuse leg, okay? So be real careful when you're looking at each of those. Make sure that the diagram meets the criteria that you have put on there, okay? So like on number 8, I could not assign it any other name because I do not have 3 sides that it tells me are congruent. I do not have, I don't even have 2 sides. Well, I guess, okay. So I think some people did do side angle side on this one, but remember the sides that are congruent here, you have FH in the middle that is congruent to itself, but to do side angle side, the angle has to be between those 2 sides. I can't jump around to get to another measurement, okay? Look at number 13, okay? What do I know my right angle is equal to? 90 degrees. So what do I know my other 2 angles must add together to equal? 90 degrees. If my whole interior of a triangle is 180, okay, and I already have 90 of it designated as a right angle, and I know 180 minus 90 leaves me 90 degrees. So that means when I add 2x and 3x, that's going to be equal to 90 degrees. Therefore, I can solve for x.
I did that a little bit differently.
I'm sorry?
I did that a little bit differently.
Okay, well, as long as you got the right answer, it's good.
What was the right answer?
18.
Yeah, I got 18.
Yeah. So if it's correct, I put a check mark. If it's wrong, I circle. Number 14. What is my rule about exterior angles? Exterior angles are equal to the sum of the 2 interior angles. So that means I would add my 2 interior angles that equal to my exterior angle and solve for x. Look at number 15. Again, x is my exterior angle, so I know x is going to equal the sum of the 2 interior angles. What are the 2 interior angles that I have?
90 and 25.
90 and 25. So I'm going to have to add those 2 together and set them equal to x. Solve for x. Okay. 16. What do I know the sum of the interior angles of a triangle is?
180.
180. So you're just going to add them up, equals 180, solve for x. Okay. Go ahead and turn it over. Look at number 17. Same thing here. I know that when I add them all together, they equal 180. So I'm going to have 5x plus 3x plus 2x plus 5 equals 180. Solve for x. Now let's look at number 18. What type of triangle is this? What do I know about this triangle?
All sides are not equal.
Okay, I know that I don't have all sides equal. What information do I know? What are the symbols that they have marked on this?
We have 2 equal angles.
2 equal base angles. What did we learn? That if I have 2 equal base angles, what do I know about those 2 sides? They're equal because this is an isosceles triangle. So remember, if I have equal base angles, the sides are equal, therefore 4x plus 10 is equal to 5x minus 25, and solve for x, okay? Now let's look at our proofs. We had the A, B, and C for each of them. And so if we look at the first one, 1 and 2 was given. Number 3, notice it says that angle BAC is congruent to angle DCA, okay? Now, look at letter A. When I say side angle side congruence postulate, okay, what does that refer to? What does side angle side, what is that used to prove? Congruent what? Triangles, okay? So I can't put side angle side if I don't have a triangle symbol in my statement, okay? It's an angle symbol, so if I look at just side angle side, alternate interior angles and reflexive property, I can kind of figure out based on what it has. Number 3, I know I'm dealing with angles. A, B, and C, the only one that deals with angles is letter B. Number 4, AC is congruent to AC. We've talked multiple times is reflexive. Most everybody. In letter C, I've got triangle symbol. So if it says a triangle congruent to a triangle, then I'm using side angle side. Okay. And then the next one, first one is given. Again, I've got angles marked here. And you can see that A and C are the exact same answers dealing with angles. So you got a 50-50 chance on that one. And then letter B, angle, side angle. So again, that's going to deal with triangle. Number 5. So number 2 and 4 are both going to deal with angles, because you can see in this statement, you can see that where it says it's dealing with the angles. Okay. Questions before we move on from that?
What numbers 2 and 5?
Okay, so number 2 is dealing with an isosceles triangle. So what do I know about an isosceles triangle?
It's got 2 congruent.
2 congruent sides. Okay, so I'm picking a triangle that would have 2 congruent sides. And notice that here, I really have 3 different triangles in my drawing. I've got my large one, that would be triangle ABD. I have my one that would be ABC, and then I have ACD. Okay. So if I'm looking for the one for isosceles, which one, how many sides do I know have to be congruent for isosceles? 2. So which of those triangles has 2 congruent sides?
Isosceles.
Yeah, but which would in our drawing, which one would it be? Mm-hmm. Do you see how? Oh, I'm sorry. I thought you were back. I thought you were over here.
No, I'm right here.
Okay. So like I said, this deals with an angle. Okay. So
I don't understand, since it's a congruent angle. Right?
yes. So
Shouldn't
A is
it be?
angles. No, ASA has to do with triangles.
Okay.
So AS side angle side,
Okay,
angle
these are-
side angle
these are
is all.
angles.
Yeah, and these are angle symbols. So these they're both going to be angles. This one is putting a triangle as congruent. So you're going to have triangle symbols.
Okay.
Does that make sense?
Yes.
Okay. So a lot of it is looking at how something is named, and that'll kind of help you to be able to figure out what we're talking about there. Okay. So any other questions before we move on from 4? Okay. So now what we're going to do is let's go ahead and start looking at 5. Share my screen real quick. All right, so in chapter 5, what are we dealing with primarily? What type of shape are we dealing with? Triangles. Okay, so we're really kind of diving in with triangles. And what is kind of the main theme of this chapter? We're looking at triangles, and what about them? We're looking at lines that are concurrent lines, points of concurrency. Okay, and so in the very beginning, we first learned about what a perpendicular bisector was, and we talked about, oops, sorry, Keely, I didn't realize that was open. Okay, let's see. So the first thing we talked about was what a perpendicular bisector is, okay? And we talked about a perpendicular bisector. When I hear the word perpendicular, what am I thinking? What needs to come to mind immediately when you hear perpendicular? Intersecting lines, 90 degrees, okay? So when we talk about perpendicular, we're talking about two lines that are intersecting at 90-degree angles, okay? When I hear the word bisector, what do I need to think of?
Cuts the triangle.
Cuts whatever, okay? So if it's just a segment bisector, it's cutting that segment in half. If it's a bisector, cuts it in half. So I know that wherever that cuts it, either side is congruent to one another. Therefore, if I am given one piece of information along that segment, I know that 2 times that will give me the whole segment. Or if I have the measure of the whole segment, half of it will give me each measure. Okay, so perpendicular bisectors. I have to have a 90-degree angle, and it has to cut whatever it's bisecting in half. Okay, and then 5.2 was talking about angle bisectors. So again, cutting an angle in half. But back to 5.1 for just a minute, the perpendicular bisector theorem. The main thing I want you to look at this is knowing that when I have a point on the line of the perpendicular bisector, okay? So my bisector is going to be CP. You can see that it cuts this segment in half. This side is congruent to this side, okay? AP is congruent to PB. And then point C is on that mark. So I know that the distance from C to A is equidistant from C to B. Therefore, if I have a diagram and it tells me what this measure is, I know what this measure is, okay? If I know what this measure is, I can figure out this one. Or if I have the whole measure, I can figure out the 2 individual ones, okay? So looking at the diagrams, thinking about what you know from the information. I could also look at this and say, hey, I've got a 90-degree angle, so it intersects at a perpendicular at a 90 degree, and it cuts it in half, so I know it's a perpendicular bisector. The converse of that just says, if you have your congruent sides, if you have 2 sides cut in half and there's a 90-degree angle, then you can assume it's a perpendicular bisector. The first one says, if it's a bisector, then it's equidistant and it cuts it in half and you've got your 2 congruent sides. The converse of this is saying, if you've got 2 congruent sides, it's cut in half, 90 degrees, then it's a perpendicular bisector. Okay, so remember, converse, flip-flop, that's what these are doing here. All righty, 5.2, I'm sorry, not 5.2, just the second part of this was dealing with our angle bisectors. And remember, an angle bisector, it just cuts the angle in half. So if I know the entire measure of my angle, but I can see that it's cut in half, then I'm just going to divide that number by 2. If I know one small measure, then I multiply it by 2 to find the whole entire angle. And again, on this one, the thing I want you guys to focus on is this theorem tells us that when I've got this point on the bisector, where it would come from the point to either side and intersect at a 90-degree angle, then I know that these 2 sides are going to be equidistant, okay? So when I look at my diagram, I can say, hey, this is a perpendicular bisector because these 2 are cut in half, and D is equidistant to B and C when it intersects at 90-degree angles, okay? So again, if I know this measure, I can find this measure. If I knew this whole entire measure, I could find each of those. And then the converse of that just says, if it's equidistant and cuts the angle in half, then it's an angle bisector. At any point as I'm reviewing these things, if there's something that doesn't make sense to you, please let me know. So 5.2 is where we take these two ideas of a perpendicular bisector, an angle bisector, and we start to apply them to triangles, okay? Triangles are a type of polygon. We're going to be talking more in chapter 6. We're going to be moving on to quadrilaterals. So how many sides does a triangle have? 3. How many sides does a quadrilateral have? 4, okay? So all of these things in chapter 5 that we're working on, we're going to be able to apply a lot of these same ideas when we move to quadrilaterals, because I can draw a diagonal in a quadrilateral and cut it in half and make it 2 triangles. So basically the things I've learned about triangles are going to be applied to quadrilaterals. That's why I want to make sure that we're really good with chapter 5, because it's going to help you understand chapter 6, okay? So bisectors of a triangle. We have our concurrent lines. What does concurrent mean? Concurrent means happening at the same time, okay? So if I've got my lines all happening at the same time and they all intersect, we call that our point of concurrency, okay? So remember, no matter what we're talking about, maybe we're talking about bisectors, okay? So what do I know again? What do I know about a perpendicular bisector? Intersects at what kind of angle? 90-degree angle. And whatever side it's intersecting, it's cutting it in half. So because I have 3 sides of a triangle, I'm going to have 3 perpendicular bisectors, okay? So just like this one's here, I could have a bisector coming through here, and I could have a bisector coming through here. And so that's what they show us down here at the bottom. When we look at our 3 different types of angles, and we talked about that point of concurrency. If it's an acute triangle, the point of concurrency is inside the triangle. If it's a right triangle, it's going to be on the hypotenuse. And if it's an obtuse triangle, then they actually do not intersect until it is outside the triangle, okay? So 3 perpendicular bisectors, they all intersect at a point of concurrency. Does anybody remember what that is called? Perpendicular bisectors, point of concurrency is called the circumcenter, okay? So if we move on to theorem 5.5, we have the concurrency of perpendicular bisectors, okay? So basically it says the perpendicular bisectors of a triangle intersect at a point that is equidistant, okay? So my perpendicular bisectors intersect and cause equal distance. Okay, it's not my perpendicular bisectors that are going to be equidistant. And that's the thing I want to be real careful here. Okay, so when I'm looking at this figure, the blue lines represent my perpendicular bisectors. Okay, the point of concurrency is created because of the perpendicular bisectors. But from that, I know that the distance from that point to each angle is congruent, okay? So seeing the perpendicular bisectors creates a point of concurrency. Using that point of concurrency, I know that it is going to be equidistant to each vertex or each angle, okay? So basically, when I draw the blue lines, it makes the red lines all congruent, okay? So then we can move on. And again, if I've got a figure and it tells me measures, I can use those measures to figure out other measures because of what I know about that. I'll go back to that one real quick. So again, if I knew this measure here, I can figure out this one. And I can figure out the entire length of this side. If this was 5, what is this one going to be? So what is the whole length of the side? 10. If I know that this measure here is 12, what is this one going to be? All of them are equidistant because it's from that point of concurrency. So they're all going to be 12, okay? So knowing perpendicular bisectors create that point, the point is equidistant, okay? All righty. Angle bisectors is kind of the flip-flop, all right? So when I have angle bisectors, those are my blue lines. The angle bisectors cut my angles in half. It causes that point of concurrency, okay? Now I have a point of concurrency, and I can see that now the distance to each side will be congruent. So perpendicular bisectors make the point of concurrency equidistant to each vertex or each angle. Angle bisectors create a point of concurrency, which tells me I have equidistant to the sides. So they're kind of, they go together, but they're kind of flip-flop with each of these, okay? So again, if I know the measure of P to E, then I know DP, I know FP, okay? But remember, the angle bisectors are not going to intersect at a 90-degree angle. That's only the perpendicular bisectors. What is the point of concurrency called with angle bisectors? In-center, good. So perpendicular bisectors are circumcenter, angle bisectors in-center. Done. And 5-3. We move along to medians and altitudes. Again, these are additional lines that I'm drawing in my triangle, okay? But a median, oh, it's fine. I was going, where's that coming from? A median comes from a vertex and it bisects the opposite side. What does that mean? If it bisects the opposite side, what does that mean?
It goes through.
It goes through, it cuts it in half. Okay, so if it's a median and it comes from A, goes to the opposite side, it cuts it in half. What does that mean? This side is to this side. Equal to it, okay? Is it intersecting at a 90-degree angle? No, okay? So with a median, it's going to cut my sides into congruent sides. Again, I can have 3 medians. Point of concurrency. The point of concurrency with medians is called the centroid, okay? Perpendicular bisectors, circumcenter. Angle bisectors, in-center. Medians, centroid. Now, the things that I can figure out, though, from these dealing with medians. The concurrency of medians of a triangle. In this, when I have a median, they're all going to intersect at the centroid, and I know that the longest side of my median is 2/3 of the distance to the centroid. I know that my shortest side is 1/3. Altogether, it is 3/3, which is equal to 1 whole. So if I know just this part here, let's say this part was 10. Let's say from B to P, this measure was 10. What do I know P to F is going to be? 5. So what do I know the entire measure is? 15. This is where I'm having to think about. I might have to relate a fraction to a number and say that 2/3 is equal to whatever, or I've got to put in my numbers and figure out, okay, well, if 2/3 of what number is 10? Remember when we could set that up as 2/3 times X equals 10. Solve for X, okay? And then once you know what that whole number is, then you can figure out what that is, okay? Usually the numbers are going to be pretty, it's not going to be anything super confusing where you've got to have decimal points or anything like that. They should be pretty good numbers that you're able to figure out what the 2/3 of the number is. But just remember, median, you've got to know that the longest side is 2/3, the shortest side is 1/3. Altitudes. Okay, so now altitudes, there are 3 altitudes, all right? Altitudes leave from a vertex and they intersect the opposite side at a 90-degree angle. Our median left a vertex. but it bisected this side. Now what we're saying is this has to intersect at a 90-degree angle. Therefore, either side will not be congruent. Okay. Again, they all intersect. They have a point of concurrency. This point of concurrency is called the orthocenter. Good. So now we know that we have 4 different types of lines that intersect at a point of concurrency, and they all have their own little names. Isn't that special? All right, so we can see here that when we're drawing our different lines, you can see here we've got our acute triangle. We can see how we would have the orthocenter inside. We can look and see if we had a right triangle. We can see how that would go from there. This one would come straight. Actually, what would my going from L, how could I intersect this side at a 90-degree angle? From L to M, well, it's got to go at 180, but notice that it's actually this would be the line, okay? And then for K to M, same thing here. So the point where they're all going to intersect, where they're all going to cross over, is going to be right there. So my 3 altitudes, because it has to intersect the other side at a 90-degree angle, if I came out at any other point from either L or K, it would end up being slanted and it would not intersect at a 90-degree angle. So actually, these legs are also altitudes, okay? And then we can see how when I have an obtuse triangle, you can see how we had to extend. You can see how Y to Q would go that way. We can see that R is going that way, P is going that way. They're all going to intersect right there. Okay, so they actually, we have to extend them beyond. Concurrency of altitudes. So it says the lines containing the altitudes of the triangle are concurrent. If AE, BF, and CD are the altitudes of triangle ABC, then AE, then line AE, line BF, and line CD intersect at some point H. So again, you can see where they would extend beyond and intersect. All righty. 5-4 mid-segment theorem. How many sides do I have of a triangle? 3. What do I call, if I have a line, what do I call the halfway point on a line? If I have
Mid segment.
if I have line AB, what am I going to call that point in the middle? Midpoint. Yeah, it's a midpoint. So basically the mid segment is made up when I connect the midpoints of triangles. And so since there are 3 sides, like I would have a midpoint here and a midpoint here, so I could connect there. Excuse me. I would have a midpoint here and a midpoint here, so I could connect there. I could have a midpoint here and a midpoint here, so they would connect there. So mid segments are created when I connect midpoints of 2 sides. Okay, and the main thing to know about midpoints is they are 1/2. The midpoint, or the mid segment is equal to 1/2 of the measurement of the side that is parallel to. So if I'm looking at this one, it is going to be parallel to that side. So my mid segment is 1/2 of the length of my longer side. When I look at my mid segment here, it is parallel to that side. When I look at my mid segment here, it is parallel to this side. So mid segments are 1/2 of the segment that it is parallel to. I don't believe on the test there's anything where you're having to use midpoint, where you're having to draw the triangle beyond the segments. So basically, mid-segment theorem, your mid-segment is half of the segment that it is parallel to. Alrighty. Like I said, this part here where we had to find the slope of each side to find additional points is not going to be on the test. And then inequalities in a triangle. Okay, this is the section where we looked and we said we can look and we can identify the longest and shortest sides of a triangle based on the smallest and largest angles of a triangle. And we can identify the largest and smallest angles of a triangle based on the longest and shortest sides of a triangle. Okay, so basically we've got that relationship. So the shortest side is going to be opposite the smallest angle. The longest side will be opposite the largest angle. So if I'm given 3 angles and I need to put my sides in order, then I'm going to look and say, hey, this is my smallest angle. Therefore, this is my smallest side. 45 is in the middle. So this will be my middle side. 100 degrees is my largest. So that would be my longest side. Okay. So when I'm dealing with inequalities, I'm not saying that anything is equal to each other. I'm saying one is smaller. So one is less than something, which is less than something else, or one is greater than another, which is greater than another. So remember that if it says inequalities, I'm using inequality signs, greater than or less than. Now we have the exterior angle inequality. On test 4, we had the exterior angle equality, where basically, sure. With the exterior angle equality, we learned that this exterior angle is equal to the sum of these two. When we're talking about the exterior inequality, we're saying that this angle is going to be larger than this angle. This exterior angle will be larger than this interior angle. Okay, so we're looking at them separately, not added together, because if I add them together, they're going to be equal to that. Okay. Our triangle inequality theorem just says that the sum of any 2 lengths of a triangle is greater than the third side. So it doesn't matter which 2 sides I add together. If you're having to test numbers to see if they could make up sides of a triangle, you're just going to add them together and say, hey, if I add this side and this side, is it larger than this side? Yep. If I add this side and this side, is it larger than this side? Oh, no. Then they cannot be measurements. Okay. So the sum of 2 sides is always greater than the length of the third side. Ooh, all right, so our indirect proofs, again, basically is looking at, and we're not going to spend much time on this, an indirect proof is a proof in which you prove that a statement is true by first assuming that its opposite is true. Okay, so you go opposite, which leads you to the assumption of the first thing being true. All right, there's the bell for the break. So let's go ahead and take a break and we will come back and keep on. April, you're good, honey. Okay, the video will be posted online so you can catch the rest of it. Okay,
Yes, ma'am.
okay, feel better, all right?
Thank you.
You're welcome.
again?
What did you not?
There was a guy wearing a plastic mask and a mask on the left.
That's crazy. Yeah, a lot of people are saying like that.
I know.
But that sounds too excessive.
3 months when we go into the field.
Oh, man.
Gotta get that word.
I'll be getting that letter.
Hey, all season's gone, so.
Whenever
you wanna go.
And then when I get back from Indiana, I'll get my license. And I can work around. I'm just a few for 5 months. Can you come back 6 foot, 200?
6'5", 250 pounds.
Yes. At least. Maybe 3. I'll be the white incarnation of Derrick Henry. I mean, if you were that big, you'd be working out like him.
Low key being small though. Like you can
Sucks.
just like you can get
Everybody
low
tackles around his
You can
head.
get like lower than everybody.
Yes,
and,
but-
like just
But I have no weight, so they can just tackle me.
You-
Yeah, they just
You
did,
remind
they
me
literally
of-
did this in the game. They literally just did that and moved on.
you remind me of Sean Shivers.
Stove.
That's like,
Stove. Nah, I'm trying to be like Tank.
dude, that tanks are
Tank's a
tank.
tank.
Dude, I'm trying. Dude, Seth Williams though. Seth Williams. Man.
I don't know, like 40 pounds.
Here, is she very 4'5", 5'5"?
She's on like I think end of 4'4" or beginning of 5.
She's at the end of my life.
Well, I didn't pay attention. Sorry, bud.
When we go over.
I wasn't either. I
everybody
just kind of sat there with the blank stare.
When we go over the homework, everybody asks questions.
I mean, yeah.
For once, I didn't have any questions on the homework. I'm so proud of myself.
ESPN gave Auburn an 86% chance of beating Tennessee, and I'm like, I don't know about that.
I don't know about that one, too.
I was like, I don't know about that.
Hey.
Shanker's got Spotify
Wait, really? Where?
right next on the bottom. It's blurry on Spotify.
Sorry.
What's on Spotify?
Riley commented on my post and goes, "This is a beast."
Why are you looking at it from the side? Look at it straight up.
I'm drawing, but I can't tell what it is.
That's Spotify.
It's not Spotify. There's why on it. That's all I know. You're not. Look at that. Ooh, the balls right there. Look at that. And there's me and Harris. When I had it.
1 inch off the ground.
I was coming down already. The way he got so high that he was already pushing me down when I jumped up. That picture.
Dude, Harris got hot stuff.
And this,
Derek.
look at it. I'm all the way to the left. I just think so fast. I need to be faster. What are you doing? I think it's fine. He's just knocking because he's bored.
Not getting to go outside. Actually, like to go outside.
What?
Titus is just staring at you.
Oh, I hate
Hey, which one is it?
that. Is okay. He's
Titus?
annoying.
Titus is a king.
Ugh.
Titus is a king.
Oh, I hate that. His last name is King.
Titus is a queen.
That works. Oh, Lucas will buy me this for my birthday.
That's not what I actually said.
What's that? No. It's automatic launcher.
You just hate ties because supposedly or supposedly.
I guarantee you the only people that buy that are NFL. I also dated his sister earlier this year.
There you
Because he
go.
hates me for that too.
They didn't.
I did. His
You
sister
don't
is
need
Sarah.
They said they didn't.
Oh, got him. This is what I made 25 years ago. Put that boy in his face.
Muffin, I got a question. You know like everything about like diet and healthy food. What food makes your hands big?
I wish I knew.
Cause I need that.
Oh.
Well, our hands are the same size.
I wish I knew, but I do get like extra
What?
large gloves, so my hand.
Whatever happened to that blog?
Dude,
Turn the block.
I got
didn't do anything. I wasn't making that.
hot dang today.
Our bags.
Would you have like 11 people look at it or something?
No, I had like over
I
300
think-
people look at it a week.
Nobody signed up.
Okay.
Well, I don't know.
Okay.
I never really kept up with it.
I know, and I tried to get you to keep up with it, and you're like, oh yeah, I'll put something else on there, and you're like, yeah, I forgot you.
Hot dang
just
today
supposed
grew
to
their
know,
hands by
recommend
5
having
times size.
Oh, sir,
You can up in the studio.
you better add some vocals. I'll come over and we can add some words.
I don't have any other things about
Tricky. Get it, buy more.
that. That's why I'm like, you know, how much other things
How much?
I can-
And all your other stuff wasn't that much?
It was.
Just get some,
Exactly.
It's hard.
What
just
kind
get
of
some
music y'all
cheap
make?
auto tune. Get like a free one that's on like, I don't know. So many
Y'all make
websites.
it rap music.
Yeah, I mean,
I used to be able to rap a little bit, and then I realized I'm a white boy. I was like, nah.
I made one.
And
video.
Eminem is like pretty much
I'll
only
see if I
good.
can find it.
Well, all
White
your
rapper.
beats were good. 2 of them were just lo-fi, and then you're like, why am I making this? And then you make a rap.
Eminem is
Don't disrespect NF like
Frick Eminem. NF is better.
that. Eminem diss Machine Gun Kelly. I like Machine Gun Kelly.
This is like Angry Birds.
Hey, don't disrespect my guy like that. Angry Birds
She's
sucks.
out like.
Dude, I love like the hard beats that just like draw. Like, I
Even
mean,
the ones that have.
like have you heard that?
foundation
Have you heard the? Have you heard Devil's Work by Warner Lucas? I want to rewatch that beat tonight.
I can't wait to go to my English for myself. Before my mom was like, all right, let's start it up. Just use it for like 5 minutes, and I was bumping to Juice WRLD the whole time. This came out, and I was like, oh, gotta change that. That's pretty great.
I don't know, but I like some chill stuff.
Like what?
What is the Jennifer doing exactly?
Yeah,
It's pretty fun, because I don't even have to use the chords, I can just actually have it. It's so cool. Wow. And I can watch movies on it.
There's not a lot by
I can
itself.
watch movies.
Oh, Mrs. Jennifer.
Sorry, the copier was giving me fits and I had a big print job in there and it wouldn't let me cancel and it kept jamming.
4, 4, 4, 6, 4, 7, all on the back of my notebook. They have notes. All from
Watch YouTube.
Where are the notes? Like, where does it say lesson notes?
right here, right. 1.
Is that what that is? Okay, so
Yes.
you've got to read them. I gotta know, I gotta be able to look at it and know what it is, but now I can see. Okay, all right.
Oh, my notes are down.
Baby steps. I'll take it. All right, sorry, hon. Okay, let's get this going back.
Dude, I don't know how confident or what. One-on-one, I feel like.
Miss Jennifer,
Yes.
on number 8 and 11,
On what?
the test,
Uh-huh.
you marked me for half a point, but I got it wrong, so.
So 8 and 11, like if you put yes, but you chose the wrong thing, or if you put something on there, I assumed you meant yes, but you put the wrong measurement, then I only counted half off because tell what it is, but you got the wrong part of it. Does that make sense? So I didn't want to count the whole thing wrong. So I wanted to give you credit for recognizing that you could figure it out, but the half was because it was the wrong reasoning. I thought it was sharing screen. Come on. Start. All right. All righty. Goal 2 in 5, 6. Yeah, 5.6, goal 2, dealing with the hinge theorem. We talked about this, right?
We're at 5.6. We're on 5.5.
Well, I had just changed to 5.6, talking about indirect proofs. And we talked about how basically it's just saying that you're starting out assuming the opposite's true, and then you end up proving it indirectly. We're going to kind of move right along. Have we talked about the hinge theorem yet? Okay. So the hinge theorem just says that in the two triangles shown, notice that AB is congruent to DE. Okay. So it's where I have two different triangles. And I can see based on the hash marks that it says that AB is congruent to DE. Therefore, if I know this measurement, I know this measurement. It tells me that FE is congruent to BC because it's got the two marks. Okay. So it says if those are congruent and this angle is 122 degrees and this angle is 85 degrees, then I know that this side will be longer than this side because this angle is greater than this angle. Does that make sense? So basically it's saying that these two sides are the same. These two sides are the same, but even though the distance of those two sides are the same, if one has a larger angle than the other one, then the third side will be different numbers. Okay, just because the two sides are the same doesn't mean the third side will automatically be the same. It depends on the measure of those angles. So that's what it's telling us there. That's what the hinge theorem is, that if two sides of one triangle are congruent to two sides of another, and the included angle in the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. The converse of that says if two sides of one triangle are congruent to two sides of another, and the third side of the first is longer than the third side of the second, then we know the included angle of the first is greater than the included angle of the second. So that's the hinge theorem. All right, and so basically that's what we looked at here, where we could see that I've got my two sides are equal and I'm looking at my third side. I think we left off, this is where we left off, was comparing distances maybe. I don't think we had talked about this, but basically it just says travel distance. You and a friend are flying separate planes. You leave the airport and fly 120 miles due west. Then you change direction and fly west 30 degrees north for 70 miles. It says west 30 degrees north indicates a northwest direction that is 30 degrees north of due west. Your friend leaves the airport and flies 120 miles due east. She then changes direction and flies east for 40 degrees south, flies east at 40 degrees south for 70 miles. Each of you has flown 190 miles, but which plane is farther from the airport? Okay, so when I look at my diagrams, we can see that, okay, here's the airport. You left and went this way. I think they said you went west. Yeah, you went west and then you ended up going north. Your friend went east and then ended up going south. So which one is further from the airport? So basically you've gone this same direction here. Same direction here. So we see that these two sides are congruent to these two sides, but based on the degree of the angle is going to tell us who is further away. And so it says because these two triangles have two sides that are congruent, you can apply the hinge theorem and you can see that RP is longer than TP. So when we look at this, we can see that this one will be longer than this one because this angle is greater than this angle. Okay, and so that's just using the hinge theorem. I don't believe there's anything like that on the test. Okay, so questions on homework. Were there any questions that we need to go over from any of these sections on homework?
24 and 25 on 5.5.
Okay, 5.5.
Were we supposed to, grade it at home?
Yeah, so every time I want you to check it. And like I said, the evens you're not gonna have. I'll need to give you the evens. So if when we go over these, if you need to, and so that way, if you need to wait and bring me your homework tomorrow, that's just fine.
So I can grade it at home?
Yeah. Yeah, that'll be
Yeah, I'll
fine.
give it to you tomorrow because I didn't use 25.
That's fine. Let's go ahead and look at any of these that y'all have questions about, and then y'all can put it all together and bring it tomorrow. Okay, so we're dealing with inequalities, and it says to solve the inequality that AB plus AC is greater than BC. So basically, if I'm looking at this, I can see that if I've got AB, that's going to be x plus 2. So x plus 2 plus AC is going to be x plus 3. X plus 3 is greater than BC, which is 3x minus 2. So x plus x gives me 2x. 2 plus 3 is 5. So 2x plus 5 is greater than 3x minus 2. And now I'm just going to solve for my x. Subtract 3x, subtract 3x. I've got negative x plus 5 is greater than negative 2. Subtract 5, subtract 5. I've got negative x is greater than negative 7, but I need a positive x. So what does that mean I have to do? Multiply or divide by -1. And when I'm dealing with an inequality and I multiply or divide by a negative, what does that mean I have to do to my sign? Flip the sign, okay? So if I multiply everything by -1, x is less than 7. Good. I'm sorry?
On page what?
This is on page 299. Okay, so you'll do the same thing for number 25. Set it up where AB plus AC is greater than BC. Just use your measurements that each side gives you and then solve for X. Other questions? Any other questions from 5.5? What about from 5.6?
5, 4,
5.4?
18.
Okay, let's go back. Number 18. Okay, so it says if MN, here, let me just erase this. Okay, so it says if MN equals x minus 1 and AB equals 6x minus 18, then AB equals what? So when we look at MN, what do we know about the relationship of MN and AB? What is the title of section 5.4? Look on page
Segment.
mid segments. So what is MN? A mid segment. What do I know about the relationship of a mid segment and the side it's parallel to? Look back on page 288. Look at your mid segment theorem in the green box. I hope you guys are using your folders and writing these things down. If you're not studying these theorems, you're not going to have a clue. Okay? Make note cards, put them in your book, whatever you can do. But remember, mid segments are half the length of the side it's parallel to. So I know that MN is going to be half of AB. Okay? So I know that 2 times x minus 1 is equal to 6x minus 18. Do you see why I did that? Because if my side that is x minus 1, right here is the mid segment, it takes 2 of these to equal 1 of these, okay? So it told me that this side is x plus 1. I'm sorry, x minus 1. So I need 2 of them. I need to multiply that length by 2 and set it equal to 6x minus 18. So I'm going to distribute my 2 and have 2x minus 2 equals 6x minus 18. Subtract 6x, subtract 6x. So I have negative 4x minus 2 is equal to negative 18. I think, well, actually, that's what I've got right here. So then I can pick up with negative 4x minus 2 equals negative 18. I add 2 to each side. I have negative 4x equals negative 16. Divide both sides by negative 4. So x is equal to 4. Okay. So I'm having to use this theorem to be able to write an equation that represents the lengths that I'm given. That's why I have to understand these relationships of these lengths. I have to know that a mid-segment is half of the measure of the parallel line. Yes.
So I've figured out that. So
Okay.
now would I plug the x to AB?
Yes. So then when you look at AB, if x is 4, then I have 6 times 4 minus 18. So what is 6 times 4?
24.
And 24 minus 18? All right. So you know that AB is equal to 6. Okay. So the main thing is pay attention to your directions. Does it say just solve for x, or does it say give the measure? If it says just solve for x, then you would be done at x equals 4. But because it says to give the measure, then you have to go ahead and plug it in and give the actual measure of AB. Okay. Any other questions?
117 on 5-2.
5-2. Number 17. Okay. So in this one, again, we know that we've got perpendicular bisectors. So if I have perpendicular bisectors, what does that tell me about the distance from my point of concurrence to each angle?
And then equidistant.
That they're going to be equidistant. Okay. And so I'm looking at, let me erase this so I can see it. Okay, so basically if I'm looking, I need to focus on this triangle right here, because I know if this one, it tells me I'm looking for QN. I'm looking for this measure here, but if I know that this measure and this measure and this measure are all congruent, then I can use these two sides to find my third side. Now, when I have a right triangle and I know two sides of it, what can I use to find the third side? Pythagorean theorem, a squared plus b squared equals c squared. Okay, so if I have a right triangle and I know two sides, how can I figure out if I know that this is 7 right here? What do I know this measure will be? Or this measure, either one.
24.
24. So I know that if this one's 24 and this one's 7, I can solve for this one. What is this called? What is the side opposite the right angle called? Hypotenuse. Which of those does my hypotenuse have to be? A, B, or C?
Okay.
No,
No, I mean,
C. Okay. A squared plus B squared equals C squared. The hypotenuse always has to be C. So if I know that one side is 24, then 24 squared plus 7 squared equals C squared. Okay. 24 squared is 576. 7 squared is 49. Add those together, it's 625 is equal to C squared. Now remember, when I have something squared, that is the opposite, or that's the opposite of taking the root, the square root. So if I want to solve for C, I have to take the square root of C. If I'm C squared. If I take the square root of C squared, I have to take the square root of 625. Therefore, 25 is equal to C. So I'm able to find that that length is 25. Okay. So like I said, there's a whole bunch of things that are having to all come together. I'm having to understand here that my perpendicular bisectors make my angles equidistant to my point of concurrency. Okay, I have to use that information and now apply it to, hey, I've got this side that I know is bisected. Now I've got to cut this side in half to find a second side of the triangle. Now I need to know that I've got a right triangle, so use the Pythagorean theorem to find the missing third side. I have to know that the missing third side, if it's the hypotenuse, it has to be the C part. There's a whole bunch of things that we're having to put together in here, okay? So that's why looking and really studying these diagrams, learning the definitions, knowing them, that's the only way you're going to, you know, be able to put it all together. So,
Also, are we gonna check homework from Thursday, and we did it all? So
yeah,
we can check.
so let's take those. So on Thursday's homework was 5.5 and 5.6, right? Okay, so let's look at 5.5 real quick. Okay, so let's see, 5.5, page 298. All right, so we had 6 through 11 all. On 298, we had 6 through 11 all, so you should have been able to check your odds. We'll call them out anyway, but we'll go through those real quick. Number 6, this is on 298, section 5.5. Number 6. It says name the shortest and longest sides of the triangle. My shortest side is AC, my longest is AB. Number 7, it says to name the shortest and longest. My shortest will be RT, but my longest will be SR and ST because they're going to be congruent. Okay, so I actually have 2 longer sides there because they are congruent. Number 8, JK is my shortest and HJ is my longest. Number 9, now I'm telling the smallest and largest angles. Number 9, angle C is my smallest, angle B is my largest. Number 10, angle R is my smallest and angle Q is my largest. 11, angle H is the smallest and angle F is the largest. Then we moved on to 14 through 19 on 299. It says to list the sides in order from shortest to longest. So number 14, AB is less than BC, which is less than AC. So AB, BC, AC. Number 15, DF is less than DE, which is less than EF. So DF, then DE, then EF. 16, HJ, GJ, GH. Then 17, 18, and 19, we were doing angles from smallest to largest. So in number 17, it goes angle L, angle K, angle M. 18, angle N, angle O, or Q, sorry. Angle N, angle Q, angle P.
Wait, could you repeat number 8? Yeah, 18.
Angle N, angle Q, angle P. Number 19, angle T, angle S, angle R. Then we jump to 24 and 25. 24 we just looked at, where we said I would set it up to where I would add sides AB plus AC, and that's greater than BC. So I end up with X is less than 7. We had to flip our sign there.
5, 6.
Huh?
5, 6.
No, we're on number 24 on page 299. We had numbers 24 and 5 also. So we had 14 through 19 and 24 and 25. And so on number 25, again, we would set it up to where AB plus AC is greater than BC. So X is less than 7 again.
I got X is less than 80.
Okay, so let's take a look at it. If I add AB,
Added X plus 2 plus X plus 4 is greater than 3X minus 1.
okay, so X plus 2 plus X plus 4 is greater than, out of room. Hold on. All right. x plus 2 plus x plus 4 is greater than 3x minus 1. Okay,
Then I said, I put the x's together to get 2x plus 6 is greater than 3x minus 2.
minus 1.
So
That's where you messed up. Yeah, it's 3x minus 1. So then subtract 3x, I have negative x plus 6 is greater than negative 1. Subtract 6, negative x is greater than negative 7. Therefore, x is less than
so
positive
both
7.
24 and 25 are
Both the same answer.
Okay.
Yep. All right. Then we moved on to 5, 6. And 5, 6 on page 305. We have got 7 through 15 all. So on page 305, it says use the hinge theorem and its converse, and we're using greater than, less than, or equal to. All right, so number 7, RS is less than TU. Number 8, the measure of angle 1 is equal to the measure of angle 2. Number 9, the measure of angle 1 is greater than the measure of angle 2. Number 10, XY is greater than ZY. Number 11, the measure of angle 1 is equal to the measure of angle 2. And number 12, the measure of angle 1 is less than the measure of angle 2. 13, AB is greater than CB. 14, UT is greater than SB. And 15, the measure of angle 1 is greater than the measure of angle 2. Questions on that? And then on 306, we had 16 through 20 all.
You had that.
I don't have it written on here. I just read it in my book. Okay, so let's take a look at it.
What is that?
You don't have to do it. Okay, let's just look at it and talk about it. Okay, so it says in exercises 16 and 17, match the given information with the conclusion A, B, or C and explain your reasoning. Okay, so let's look at letter A. Says AD is greater than D. So let's look at this. Okay, if I have AD, is that side going to be greater than CD? It says, oh, sorry, I guess not just looking at the figure. It says AC is greater than AB and BD is equal to CD. So is AD greater than CD? Is AC greater than BD? Or is the measure of angle 4 greater than the measure of angle 5? So if AC is greater than AB, okay, I can look at those two sides and I can see that AC, based on what they've told me, is greater than AB. Therefore, what does that mean about angles 4 and 5? Which one will be larger? If I'm looking at this right here and they said that AC is greater than AB, okay? So 4 is the opposite angle of this side. 5 is the opposite angle of this side. So which angle is going to be larger?
5.
Number 5. Angle 5 is going to be larger. Therefore, look at letter C. Measure of angle 4 is less than the measure of angle 5. Okay, so that was my option there. By knowing that one side is larger than the other, remember, this is where I've got my opposite sides. So that's where I look and say, hey, if this one's larger, this one's longer, this angle is larger. Look at number 17. AB is equal to DC. So I know that this side is equal to this side. The measure of angle 3 is greater than the measure of angle 5. So if I'm looking at 3, that's opposite of that. 5 is opposite of that. So what can I conclude about BD and AC? Look, it says the measure of angle 3 is less than the measure of angle 5. So this angle is less than this angle. So what do I know about my sides? Which one's the smaller side?
BD is smaller
BD is smaller than AC. So AC is greater than BD, letter B. Okay. We'll go ahead and stop there. All righty. Okay, so on the test, you're going to need to know about the relationship between angle bisectors, perpendicular bisectors, that when I have perpendicular bisectors, I know that the point from my, the point of concurrency is equidistant to each angle. You need to know information about perpendicular bisectors, angle bisectors, medians, all that good stuff, and where they intersect, those points of concurrency. You need to know about mid-segments and how they relate to the side that it's parallel to. You need to know about yeah, tomorrow. Okay, you also need to know about medians being 2/3 on the long side, 2/3 on the long side, and 1/3 on the short side. So you need to know about medians. Medians, mid-segments. You need to know about how to list the sides of a triangle in order from shortest to longest based on my smallest to largest angles. You need to know how to list angles in order from smallest to largest based on the shortest to longest sides.
Will the test cover the whole entire chapter,
Yeah, chapter 5.
like the whole thing?
And then it will end with hinge theorem. So you will have a couple of things with hinge theorem. So understanding that if I have two sides that are congruent, how can I figure out which side is longer based on which side or which angle is larger? Okay. And that's all it's going to cover. That's basically what we just said. So perpendicular bisectors, angle bisectors, medians. There's not anything on here with altitudes. Okay. All righty, so we have just a little bit of time left. I want to go ahead and introduce chapter 6. This is where we will start tomorrow. Go back through, and I'll just wait and take up all homework tomorrow. So if you want to hang on to it so you can review for the test, go back through your lesson notes. Hopefully in your lesson notes, you wrote each of these theorems. If you didn't, then go back through your textbook. Make a note card for each bit of information that you need to know to be able to study, to understand what each of these things mean. All right, so 322, we're starting with chapter 6, dealing with polygons. And so it says, a polygon is a plane figure. What does plane mean? P-L-A-N-E.
It's a flat object that doesn't have any depth.
All right, good. So we're talking about our flat surface, kind of like a tabletop. We learned about planes in the very beginning of the year. So it's a flat surface. It has no depth. So remember we talked about how I could stack 1,000,000 planes on top of each other and it would take up no space. Okay, that's hard to comprehend because if I stacked up 1,000,000 pieces of paper, and a paper, paper is kind of one of the thinnest things that I can kind of refer to. I mean, I guess you could go tissue paper and think, even thinner, but even tissue paper, if I stacked 1,000,000 pieces of tissue paper on top of each other, it's going to have depth, but with a plane, it does not. Okay.
So you stack the planes on top of each other, they would
Huh?
have no depth. So
If you stacked 1,000,000 planes on top of each other, they would have no depth. That's hard to wrap your mind around. But a polygon is a plane figure that meets the following conditions. Number one is formed by 3 or more segments called sides, such that no 2 sides with a common end point are collinear. What does collinear mean? On the same line, good. So no 2 points are on the same line, all right? Each side intersects exactly with 2 other sides, one at each endpoint. So basically, when I've got a figure, it's made up of sides that all touch one other, or I guess 2 other sides, only at one point. There cannot be more than 1 point on the line. So here you can see where each point where they meet is called a vertex. So a vertex makes the place where my 2 sides connect, and you can see where we have sides. Polygons are named based on the number of sides that it has. And when it does say each endpoint side is called a vertex, and when you're talking about plural, it's vertices, okay? More than one vertex are called vertices. You can name a polygon. This is something very important right here. You can name a polygon by listing its vertices consecutively, okay? What does that mean? If I was going to name this polygon here, and I wanted to start at point P, could I call this PRTSQ? No, I have to name it consecutively, PQRST. Or I could call it TPQRS. As long as I am consecutive in naming it, I could call it TSRQP. As long as it is consecutive in one direction or the other. It doesn't have to be in a certain direction, and it doesn't have to start with a certain point. It just has to be consecutive. I can't jump around when I'm naming it, okay? So let's take a look at example 1 that says identifying polygons. State whether the figure is a polygon, and if not, tell why. So let's look at letter A. Letter A, each line intersects at 1 point, right? Okay, let's look at letter B. Look at letter C. Look at letter D, E, and F. Think about our 2 rules that name a polygon. First step, is it formed by sides? What is the only one up here that is not formed by a side?
E.
D. Yeah, I've got an arc here. Okay, I've got a rounded part. Remember, sides are going to be straight from one point to another. And so I know that D is ruled out. The next one says each side intersects exactly 2 other sides, each at one endpoint. The other part of number 1 said I cannot have any 2 sides with a common, no 2 sides with a common endpoint or collinear. So which one, what's ruled out by that one? F is ruled out from that because you can see where these sides intersect with each other. Now I could make these 2 polygons, but this one whole figure does not fit the criteria. What is wrong with E? It doesn't connect. Good. My sides do not join there. So I can see that D, E, and F are not polygons. Okay. Then we have polygons are named by the number of sides: 3 triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 is a dodecagon. I do not know. 11 again. But notice that anytime you're talking about a figure and it has an unknown number of sides, if you're having to figure out what type of figure it is, they call it an n-gon, because at the time you do not know what the number is. So they're letting the variable n represent the number of sides. We still got about 5 minutes. Okay, so notice here it says a polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. Okay, so notice that each of these lines, if I were to extend them all out, at no point would they go into the figure. So that is called convex. Concave means that if I were to extend the lines again, so if I extended from this point over, then it's going through the figure. So that is called a concave. So a polygon that is not convex is called non-convex or just concave. So look at number A and look at example 2, A and B. If I were to extend all of my points, what do I notice about this one? Is this convex or concave? Concave. And so one of the things, like if you think about concave, is it's going to kind of fold into each other or into itself. And then B would be convex. So you can see here where they drew the lines. So you could see that if I extended this side out, it would go into itself. If I extended this side out, it's going to go same thing with this one. Okay. A polygon is equilateral if all of its sides are congruent. A polygon is equiangular if the interior angles are congruent. A polygon is called regular if it is equilateral and equiangular. Okay, so just like we've talked about equilateral triangles are equilateral and equiangular. The sides are all equal to each other and the angles are all equal to each other. So if we look at letter A, I have my sides all equal to each other, but are the angles all equal to each other? No. No, these two are equal to each other and these two are equal to each other, but they're all four not equal to each other. So this is not a regular quadrilateral. Same thing when I look at letter B. What do you notice here? I've got all my sides are congruent. Are all my angles congruent? Yeah, the same. I have one arc. Remember, if I'm showing that they're different, one arc, two arcs. So if it's a single arc on each one, it is showing that they are congruent. So this is called a regular pentagon. 1, 2, 3, 4, 5. So this would be a regular pentagon because all sides are equal, all angles are equal. What about letter C? Is it regular? No. Why? Sides are equal, but what about the angles? Not going to be equal, right? Okay, so because you can see that this is going to be an obtuse angle here, that's going to be an acute angle. So I know that they're not, yeah, it's a Pac-Man. So I know that it is not going to be the same. All right. Quickly, we are going to look at goal 2, diagonals. A diagonal of a polygon is a segment that joins two non-consecutive vertices. Remember, if they're consecutive, it makes a side. So QR is a side because they're consecutive. But if I draw from Q to S, that's called a diagonal. So this is where we'll pick up tomorrow, is dealing with our diagonals. So homework for tonight is to check your homework to be turned in tomorrow. Make corrections to test 4. Study. I will give you here's my concern. Okay, if you can get them done, that would be fantastic. My concern is that we have Thanksgiving next week, and so you wouldn't be turning them into the next week. As long as, and I guess it's the kind of thing where as long as you get them to me realistically before we get out for Christmas, I'll be able to grade them and get your grade finalized before Christmas. Just don't forget about it. Don't lose it is the main thing. Okay, so keep up with it. Hold on, the bell hadn't run. So we've got check your homework, get it all ready to turn in tomorrow, study for your test, and corrections if you have time to get it done and turn in tomorrow. Okay, so tomorrow we're continuing in chapter 6. Your test will go home, and then we'll be out for Thanksgiving.
You think by any chance you could teach algebra 2?
Negative.
No.
Now I told you no about geometry, and here I am, but algebra 2 will not happen. All right. Let me know if you have any questions, Keely. We'll see you tomorrow.
Thank you. Sorry.
See you tomorrow.
Yes, ma'am. See you tomorrow. Thank you.
Hey, let me know if you have questions, okay?
Yes, ma'am.
Bye.
Not you.
I mean,